All right, people, triangles. First day of triangles. What do you know about triangles? What do we know? Three sides. That's a good place to start. No, they don't always have to be the same. They can be. They can be. Ah, that's an interesting point. We have three sides and we have three angles. And one interesting feature about triangles is that all three angles have to add up to 180 degrees. And I'm going to show you a really quick way to believe that. Look. I think I did, but if I didn't, I'm showing it to everyone. So here is a normal, everyday garden variety triangle and my keys. I know I showed a couple classes this, but I didn't show them all, and I'm recording it, so I'm just going to put it up for everyone to see. So angle 1, angle 2, angle 3. And now if I cut them out, and it doesn't matter how I add them up. Yeah. Yeah. Huh? I can't hear you. I did. I'm recording down here. I'm under control, thanks. Okay. So the sum of the angles of a triangle add up to 180 degrees. All right. Now, let's put that in here. So, most important rule today is that the sum of the angles of a triangle is 180 degrees. And it's for any triangle. Yes. Yeah. Okay. Now, we're going to use that to be able to solve problems. So, if you have a triangle and you know two of its angles, you can immediately get that third one. Okay? And that's something that's going to have to become basically reflex. When you see two angles, you immediately find that third. So let's do a simple one. All right, so here we have a triangle. I know two of its angles. I need to set up an equation to find x. How am I going to do it? Well, let's set up an equation first. All right, go ahead and do it on your own. See what we come up with. Good, I'm hearing some people whisper it out. All right, so 72 plus 53 plus x is 180. So now 125 plus x is 180, and x equals 55 degrees. All right, so now what we basically have now is another tool to put in our toolbox. We know about parallel lines, I hope. We know about linear pairs. We know about vertical angles. Okay, gum. We know, shoot. Well, we know the distance, the midpoint, and the slope formulas, but that's not going to really help us right now. But in terms of all of the shapes that we know how all of that algebra begins to work. So let's see if we can put something together that uses some multiple tools. All right, so we have two triangles that are touching, sharing a side. They're adjacent. Let me fix my vertex here. Okay, so what am I going to do? How? Say it again. Well, there are two different ways of solving this. Set it up and solve, if you know what you're doing. There are different ways of solving it. Some people might say, hey, look, I got a triangle on the left and a triangle on the right. And if you look at the triangle on the right, you don't know that. But you can get it, can't you? Find that guy first. Okay. So this was, let's give it a name. Let's call it Y, because I'd like to have a name for it. It's lonely without a name. Right? So now we have 115 plus Y, 180. Y is 65. And we're good. Okay, well, that's wonderful, Ronco, but it's not helping me get my X. But can it? How? Well, I need another thing in there. I don't have the other part of that triangle. What about this guy? How do I find him? Let's give it a name. Let's call him Z. How do I get Z? Okay, what we have here is a linear pair. We have a linear pair right there. So that means that Z and 65 add up to 180, right? Right? Right. Yeah. Okay, good. So find Z for me. Mm-hmm. Yeah, if I find Z, how am I going to find Z? Okay, what do you get? Z plus 65 is 180. Wait a minute, didn't we, well, wait a second, look at that. I got 115 there, and I got 115 there. Is that a coincidence? It might, I don't know, we'll have to see. Huh. All right, swatting a fly. So now I'm inside the triangle that'll give me my x, and I can do the sum of the angles there. And now go ahead and find x. Couple people? 40. Hmm? I'm talking about this triangle. Huh. 40. Now, believe it or not, what's that? Exactly. You could have done it in two different ways. And some people jumped to another way of doing it, which we're going to look at right now. You know what? Just adding up all the numbers and setting it equal to 180 is a really bad idea. Because I could throw a problem at you where all sorts of numbers are in there. And if you just say, oh, hey, look, I got numbers, mush them together and set it equal to, oh, no, bad idea. Let's not do that. So let's, stay away from the pray to God that we don't get a decimal after we add everything up and solve for x. Okay, let's get away from that, all right? Because what you do have is a giant triangle. And that angle, and that angle, and that angle are a triangle all by themselves. And this one right here, that's 100, right? So 100 plus 40 plus x equals 180. And that'll get you the same thing. So there are different ways of solving some of these problems. But, let's see how you do when I give you something with a little bit more fangs and teeth. This month. Guys, math. Let's see. Try this one. So we have all these tools in our toolbox. We have linear pairs, vertical angles, sum of a triangle, parallel line stuff, all these things. But we don't have parallel lines in here. What? $47, 51, 33, and x. Solve for x. Yeah, so that's great. Mush all the angles together and come up with x. No, that's not going to work here. You can't. One triangle at a time. If you add up all your angles, you're going to just get it wrong. So understand what you're doing and don't just pray that it'll all work out if you just add them all up. It's not going to work. Okay. How do you know? What did you do? Good. Good. And that'll allow you to go down into the other triangle. What'd you do? Hmm?
I made this angle like y.
Okay.
Y, but I don't know which one I have to pick. Like,
Well, you don't know a lot about the bottom triangle, but you know a little bit more about the upper triangle, right?
yeah.
So work with the thing you know the most about.
Can I put like x or another?
Call it anything you like, just don't call it X. Since you know more about the upper triangle than you do the lower triangle, look and work where you know the most. No. One triangle at a time. Can't just push it all in there. Doesn't work. Yeah.
No, tiene que ser el de arriba.
How did you get the 151? Okay. So you have to find the vertical angle first. Once you find the vertical angle, then you can go down into the lower triangle. Yes. Good. That's exactly how to do it. All right. I'm seeing some people come up with the right answers. What'd you get? Good. You can add a variable if you want. You got 29? Good. So did I. Take a look. Pass. Grab pass. All right. So since you know more about this upper triangle, let's work with that. Okay. So I have two of the angles. I can find the third, and when I find the third, and let's call it y because I need a name for it. All right, great. I found that. Now, that's vertical. And now you can go into the lower triangle and play with him. And so 100 plus 51. All right. So there are different tools to use in different situations. Okay. All right. As soon as I get one pass back. All right. So how does that feel? Feels okay? It's just like using the different tools one after another, piece by piece. Okay. Let's see how we're doing on this. That's all you need. Find me A, B, C, and D. Find me all four. Oh no, it's work. I know. It's like you were cool until about 30 seconds ago. So let's find A, B, C, and D. Some of them you can get right away. Yeah, all right. You got to find all A, B, C's, and D. You got to find them all. come. He's been trying to be slick.
I've been doing this too. I was just kind of tasting it the whole time.
Yeah. For what? Which one? Okay. I'm cool with it. All right. Keep going. So now we got to find all the others, right? Which one can you find right away? C. A lot of people went after C. How do you get C? So right angle, right? So if these two add up to make 90, what's C? What other things can we get? You can get B. How do you get B? Why? Why is it 70? Is it because 70 is just a happy number? Because they're supplementary? Because it's a linear pair. And now you can find D and A. Hmm? Hmm? Sure. All right. It's using all the different pieces, all the different parts. Huh? 70 because B and 110 are supplements. They make a straight line. It's a linear pair. What's A? 70. Because A plus 40 plus 70 equals 180, right? Yeah, you see 110 twice. What about D? Who was working on getting D? 20. Okay. All right, so basically, using just the stuff that we've learned already, one piece at a time, you can kind of chop apart and turn a complicated problem into lots of little smaller problems, okay? Which are much easier to deal with. All right, let's see how well y'all are paying attention. Yeah, I know. I love that look right there. It was just like, it was like, oh, he's working a problem. He's working a problem. Oh my God, what is that? It's like, what is that mathematical abomination that you have put on the board? Huh? Yeah, grab the pass. Solve this. Good. Because he doesn't need it. He doesn't use a calculator, so therefore he doesn't need a calculator. It's like an addiction. The more you use the calculator, the more you will need the calculator. Yes. Okay. Now there's something I want to show you in this problem. Like there's a neat little thing that's happening in here. No, it's not a hurricane. I'm still waiting for a hurricane to be named after me. There we go. That'll do it. I will come and destroy all of your equations. Just wipe them all out. Ah, there we go. All right, so let's find this guy first, right? All right, so we'll just give it a name. We'll call it y. So now y plus 88 plus 32 is 180. Y plus 120 is 180. Y equals 60. Okay, great. And now we got to find x. And x and y are supplements, right? So if I go 180 minus 60, wait a minute. What is this sorcery? Sorcery. Mathemagic. But wait a minute. Are you telling me, is this some sort of coincidence? No. How to solve a certain kind of problem. Yeah, this is not the Illuminati, I promise. Because, because it is a rule. The first rule of the Illuminati is that there is no Illuminati. Okay. But wait a minute. Wait a second. Does this always work? Let's see. All right. Now, watch. Pay attention, please, because, hey, I'm trying to give you a important fact. Okay, I got a triangle and I got a straight line. So we know some things are true. We know that A, B, and C add up to 180 degrees because it's a triangle, right? They all add up to 180. So A plus B plus C equals 180. And we also know about C and D, don't we? We know that they add up to 180 also. Pay attention to this. And if you remember your algebra, okay, if you remember a little bit about your algebra, there's a property that says if two things equal the same thing, then they're equal to each other. So for example, if I say that your age is the same as her age, which is the same as her age, then I can say that your age is the same as hers. Does that make sense? It's like they're all equal to each other. If two things are equal to the same thing, then they're equal to each other. So since both of these guys are equal to 180, then the two of them are equal to each other. And now we can just subtract the C from both sides. And now what we have is an interesting little rule. And the name of this rule is called the exterior angle theorem. exterior angle theorem says if I take a triangle and I pull one of those sides out, that outside angle is equal to the other two angles if I add them up. So this D is equal to this plus that. So you go inside the triangle, you go to the other side, and those two angles add up. Okay? And once you've copied it, I'm going to show you that it worked for all of the problems we've already done. We were seeing it, but we didn't know about it yet. Look. Here, 110. You go inside the triangle, and it's this plus that. See it? This guy, you go inside the triangle, this plus this. Sorcery. Huh. Bronco, what is this? Now, we didn't actually have it here, but look. This would be an 80, wouldn't it? Right, because it's a straight line. Go inside. This would be this plus that. You see? You go inside the triangle and you go to the other side. And you add them up. And, oh, by the way, if this was 29, 80 would be this plus that. Magic. Mathemagic. Pixie dust gets sprinkled everywhere. All right. Here, well, go here. Look, 115. 75 plus 40. I know, it's great, isn't it? You go inside the triangle and then you go to the opposite side. So now let's just see. Waiter, check please. Uh-huh. You're like, Ronco, no, don't do it to me, man. That's a bad one. Mm-hmm. Yeah, go ahead. So, you got to find angles 1, 2, 3, 4, 5, 6, and 7. Find them all. I know. It's like, first you're a sorcerer, then you're a torturer. I don't know. You tell me. Ora. That's a good start. What's up? Nail him? Get him? Looks good. Can't see without my glasses, so you gotta bear with me. Now it all looks good to me. Great. Nicely done. No, es bueno. Uno de tres ángulo es igual. Gracias. So, good. You just keep going. 1 and 3. What do you know about 1 and 3? Well, angles 1 and angles 3, what kind of angles are those? They're verticals. So immediately, as soon as you know one, you got the other. How's it going, ladies? Is it moving? Wait, hold on. Good. Cinco. Número 5. Obrigado. What's up? Did you get it?
I don't know. Check it out.
How can you have two angles that are bigger than 100?
Yeah.
That's a problem.
Okay. No problem.
This is equal to this plus this.
What about?
You see, as soon as you mess up this one, the rest of them fall apart. But if this one was right, these would look good. But that one fell apart. So go back to this one. Use the exterior angle theorem. This is equal to this plus this.
Okay.
Right. And what about 1 and 3? 6 is going to be congruent to 4, right? Because they're vertical. So use the exterior angle theorem first. This is equal to this and this, right? Yeah, these look good. Yeah, those look good. Yeah. Sir. All done? I don't know. Okay, yeah. Okay, your handwriting got me there. But yeah, it looks right. You're good. Okay. All right. Good. Looking good, ladies and gentlemen. Looking good. All right, so what about angle 1? 40. So that's 40 because you use the exterior angle theorem right away, okay? And that means what about angle 3? 40. And if it's all right with you, I'm going to make this a little bit bigger. So this is 40 because 1 and 3 are vertical. What about 2? 140 because it's a linear pair, right? Linear pair. They're supplementary. All right, great. What about 4? How am I going to get 4? How? Yeah, how do I get 110? All right. You could use the sum of the angles of a triangle, 180 minus 30 and 40. Okay. Or you could say, hey, 140 is this plus this. Right? Either way. But that gives you 110. Which means This is 110, right? And what about 5? That's this plus this, right? And 70 is this plus this. You could use the exterior angle, you could use linear pair, you could use sum of a triangle. You have all of these tools in your toolbox. Okay, so there's lots of different ways to solve these, but they all basically come down to the same principles, the same set of rules. Okay? The exterior method, the exterior angle method, it works. Some of the angles of a triangle works, linear pairs work, vertical angles, complementary angles if you got a right angle in there. Well, you see 160 is outside of the angle, right? Oh, so you found the supplement to it? Yeah. All right, what about this one? Let's see if I can, let's see about this. I'm going to try and do something a little bit uglier. Okay. First of all, there's this couple of important pieces in here. We got those double tick marks. What does that tell you? That they're congruent, but that means what kind of triangle is the 1, 2, 50 triangle? The 1, 2, 50. This one up here. Take your pick. That triangle. What kind of a triangle is that one? How do you know? The 2 tick marks tell me that the 2 sides are the same. What about isosceles triangles? I mean, like, we got 2 equal sides, but what also do we have? Always 180. But what do we know about isosceles triangles? 2 equal sides. Two equal sides and right, 2 equal angles. Well done. So an isosceles triangle has 2 equal angles and 2 equal sides. Also, if both of those right angles are there, think about those right angles for a second. Take a minute. Look, I got a rectangle. We all know about rectangles. What do we know about the sides of a rectangle? We did this construction, right? Oh, that's right. This class hasn't done that yet. You have to go through flex. What do you know about the sides of a rectangle? They're parallel, right? If 2 things are both at right angles to the same thing, then they're parallel. So you have a lot of stuff in there. Parallel lines. I have a transversal. Look at that long diagonal line. That's my transversal. Parallel lines. Guys, pay attention. Get to work. Hint. This and this are parallel. And there's your transversal. What do you see? Number 5? Yeah, I see a Z also. But what angles do I get out of that? You don't know that anybody's bisected. Who? Why? It's the name of the pair. It's the 50 and the 6. Take a message, will you? I'm not here right now. Thanks. Nice, Ruel. Alternate interior angles. So what is 6? 6 is 50 also. Which means you can get me 7. Which means you can get me 5. If it was cut in half, but we don't know. But we have the 50. So you can get me the 5. You can get me angle 5, right? Take this guy apart. Guys, don't just sit there. Yeah. Yes, it is. Good. Number 7 is 60. Because the sum of the angles of a triangle, again, that green triangle is 180. So you can take that apart. Good. Let's take a look. We don't know very much. What about angle 5? Give me angle 5. How do you know? How do you know? Because of the 90-degree angle, right? These two have to add up to 90. So this is equal to 40. Huh. Good. But we still need 1, 2, 3, and 4. What about that upper triangle? That triangle. What kind of triangle was that? What is it? An isosceles triangle. And what did we say isosceles triangles had? 2 equal sides. We know that from the picture. But what also do they have? 2 equal. Which angles are equal? Hmm? Why? Because in an isosceles triangle, the 2 equal angles are across from the 2 equal sides. Find me the rest of my numbers. Did you find them? Okay. How do you get 4? It's a right angle, so how do we get 4? It's 40, subtract 90, right? Or subtract it from 90. And now you can get 2 and 3. 80, which one? Well, they can't both be 80, right? Because there you got to make a straight line, right? But the exterior angle theorem says that is equal to this plus this. And again, 250s make 100, and the 80 gives me the 180 again. And this would have to be 100. 50 plus 50, or 80 minus 180. 180 minus 80, right? So what did this need? You needed parallel lines, you needed isosceles triangles, you needed linear pairs, complementary angles, some of the angles of a triangle. You needed a lot of tools. But each one of them takes apart a little bit of the puzzle. Okay? All right, everybody stand up and give me a stretch. Just a stretch. Y'all been sitting on your butts for way too long. Flex, twist, stretch. Feels better, get some blood moving. All right. Okay. All right then. All right, let's see what we got for the next. All right. Not a lot of information in here, but there's enough. We can get some of these really fast, right? Some of these you can get immediately, can't you? We don't know that yet. All this triangle is isosceles. So wait, right up in here, that 100, use that 100 to get 6 and 7 right away. Do that first. You got 6 and 7, you get them all. You got 6 and 7. 6 and 7 you can get fast. And what kind of triangle is the 3, 4, 7? 3, 4, 7 is isosceles. So what does that tell you about 4 and 3? What was that? They are the same. 4 and 3 are the same. So go in and get 6 and 7 first. Get that done. Then as soon as you have 6, you can probably find 5. right? All right, good, that's fine. Well, 7 you get also. And then the 7 you use to get the 3, 4, 7 triangle. Now, that and that have to be are vertical. Yeah, so that's going to, but that's right. That 80 is good. Now this triangle, that's isosceles, okay? So this plus this plus this is 180, right? And these two have to be the same. Yeah. Well, 40 plus 80 doesn't do it for me. But if you think about it, 80 plus x equals 180, right? Because look, call this x for a second, okay? So you found him. That's 80, right? So now the x, the 80, and the x, because these two are both the same, I can use that to get, 180. This plus this plus this equals 180, and that gives you x. And once you got x, then you get 2 and 1, and you're done.
So these be.
You're good so far. Yeah, you're good. You're fine.
I can erase these though, right?
You don't know those yet. Don't know them yet. But this is where I think everybody is. Ladies and gentlemen, this and this are the same. So this plus the 80, which you found, add up to 180. Find x. Yeah. Yes. Exterior angle theorem. Did you find one? I'm coming over. What's up? Nice. 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 What you got? Hey, I know that word.
I saw those just this. I did a 100. I know it's like 80 and total.
Yeah, but you see, that's the thing. We don't know that those two angles are the same. We do know that those two angles are the same, right?
But like I anticipated because this is 100, so I'm like.
Yeah, but you don't know that yet. You can't say that for sure.
But then like I got the 50s and then the 80s.
Wait a second, let me see that again. I don't believe that.
And then like I look at 100 over here, which is the same. And then 30 so it'll equal 50 for me.
Yeah, that's good. Yeah, you seem all right. You seem under control. Take a look at mine. In that 3, 4, 7 triangle, the 3 and the 4 are the same. So x plus 80 is 180. This plus this is plus that. There you go. There you go. Yeah, what about 5? Whoa, guys, I gotta get out of here too. Thanks.
50.
Did you find it?
Thanks, so.
Happy. How'd it go? Did you get it all? Yeah? Did you find it? Those two are equal. So, see if that's...
I don't understand.
Yeah, you do. Watch out. You got it. You're under control. Well, actually, you can do it that way. Yeah, if you know that that's 40.
Okay.
How do you know that that's not 40? No, because you don't know that that's a right angle. That's what screwed you up. You put in a right angle that wasn't there.
Alright.
That's what caught you. Now, so x plus 80 is 180. Okay, so 2x plus 80 equals 180. Okay, solve for x. Got one more for you. All right, but let's go through this. Wait, I need my marker. think I left my marker over here. Thanks. All right, so one moment. Let's go through this. No más, no más. No más, no más. All right, what's 6? Everybody tell me all at once. What's 6? All right, what about 5? 50. All right, great. Now, we got to go inside the 3, 4, 7 triangle. And the 4 and the 3 are the same, right? Chicle. Basura, por favor. Gracias. All right, I told you I was going to get them later. All right, so so 2x plus 80 is 180. 2x is 100. Thank you. 50. And that's how you get the inside of that triangle, right? So that's 40. And 100 plus 40 is 140. Subtract 180 gives me 40. And we're done. Did you get it? Did it all work out? Good. Now I'm going to give you a different one. All right. Now, look at that upper triangle. In that upper triangle, what kind of triangle is that? No. It's a triangle. I don't know. Maybe we come up with something else. It's equilateral. All your sides are the same. What's another, what else do we know about equilateral triangles? Oh, all the angles are the same. So x plus x plus x. Right. Look, call this x. They're all the same, right? So find x for me. We got x plus x plus x equals 180. 60. Good. In fact, that equilateral triangle 60-degree thing is super important. You'll see it all the time. It's really important. You got an equilateral triangle, boom, you got 60 degrees. I don't care how big it is or how small it is. Equilateral triangles have 60-degree angles. 60 degrees. Okay. Great. Now find me x. Stop guessing. This is the 100 degrees. Right? So how do we go anywhere? What do we do? How much? Can't hear you. What is it? How'd you get it? Right. So she found that, and because, well, what kind of triangle is that one down the bottom? It's isosceles. And I got two sides that are the same, so that means I have two Tatianas that are the same. There we go. But there's only one Tatiana, right? So the other one's got to be 40 also, right? So now I can find the x. Those two add up to 80. Subtract from 180. What do you get? 100. I know, but it was a lot more fun this way. All right, so how does that feel? Feels all right? Good. All right, so here's what I'm going to do. I'm going to be really nice. And I'm going to give you practice. Don't worry, you're not going to do it anyway until the day before it's due. No. Actually, this one's really quick. But actually, here's the deal. I'm going to give you a break about the parallel line stuff. Parallel line homework. If you haven't turned either of them in, okay, listen up. Both parallel line homework problem sets, I've put them up on the Fusion page. So if you need another copy, you go and you print them off. They're both due next class, all right? No more, nothing late after next class, okay? Because I want to end parallel and move on with triangles from here on out. All right. This episode of the Ronco Show has been brought to you by isosceles triangles and the exterior angle theorem.